Good morning and welcome to the 29th Annual Exhibit of Hydrogen Fuel Cell Technologies. It's 2023 and we've been here since the 1990s talking about this technology. We need details at the technical forum. We get into the technical details. Next on stage we'll be talking about hydrogen compressors, the European hydrogen mobility and industrial applications, and it is Senior VP of PDC Machines, Ciotti. Please welcome with me, Ciotti.
Good morning. Thanks, everyone. And thanks for having me here to describe PDC. So PDC Machines, at its core, is a manufacturer of diaphragm compressors. Diaphragm compressors have been part of industry for decades. Initially, we started off with compression systems where they had the advantage of very high efficiency, keeping product purity high, and extended maintenance intervals. These machines were normally going from a low pressure of 6, 7 bar to filling tube trailers at 300 bar. But that technology has very much progressed over the years. So at its core, PDC manufactures compressors. Today, half is for the industrial market, and fully half of this is for hydrogen, which has grown tremendously over the last 7 or 8 years. But PDC has a global reach in this market. We're a very trusted partner for many of our customers. So in the last 10 years, we've sold over 800 compressors into the hydrogen fueling market. These are largely for material handling applications, light-duty vehicles, heavy-duty trucks in Asia, and buses. But there's also a wealth of other applications in rail, barge, all kinds of applications. 300 of the compressors have been in the US and Canada, over 120 for 700 bar, and we have over 100 fueling stations with our equipment in China right now. PDC is not necessarily a household name that everyone knows. Most people know the EPC firm that might have engineered the project, installed it, designed it, or the customer that has their name on the end. But be assured that PDC compressors are many times at the core of these projects to boost the pressure from whatever it's supplied at to whatever the customer requires. 200 or 300 bar for tube trailers, 350 bar for light duty, 700 bar for light duty and trucks. So just briefly, PDC started in 1977 out of a garage, grown quickly. In '99, we did our first hydrogen fueling project with industrial gas companies that were just learning about this technology and figuring out how we were going to get to these high pressures. In the mid-2000s, that's when PDC really started getting ramped up with the industrial gas industry in general to develop these systems further with higher capacity, higher pressure, higher reliability. We expanded our team in 2015 to have more service and sales centers throughout the globe. And we're very proud to report that due to all this growth, we just opened our new global headquarters in Pennsylvania, which is in between Philadelphia and New York City, late last year. So this facility is 14,000 square meters, has our inventory, fabrication, aftermarket support, and also the sales, engineering, procurement, finance headquarters for us. We're also able to do hydrogen testing here. We test every product on helium, but we're going to have hydrogen on site this quarter after it gets permitted, so we'll be able to test even more with hydrogen. In general, PDC has, we kind of stay in our lane. We're fixed to the core of providing compressors, which we try to do very well. We have 3 main product lines. This used to have a lot of numbers on it, but I think it's difficult to understand. We basically have a PDC 3 machine, a 4, and a 13. We think about the early days of these applications. We didn't have vehicles. We were testing fuel cells out in the shop. A lot of customers were using PDC 3 equipment. So that's like a low volume machine, can take hydrogen from 6 or 7 bar up to 300, 350, or 700 bar very easily, low volume applications. Then we started getting into more material handling locations where they might need 100, 150, 200 kilograms a day. That was a perfect product suited for the PDC-4. Now what we're seeing today, this gradual change over many years, is a lot of implementation of PDC-13 equipment. This is normally used in bus applications, heavy-duty transit, anything requiring tons of hydrogen a day. But I know we're focused on mobility here, and it's the interesting topic, but hydrogen for industrial applications is going to have a big, if not bigger, impact on how technology is going to be used in a sustainable way in the future. So typically, industrial applications that we've always had for diaphragm compression equipment has usually come from a hydrogen tank at 6 bar. The compressors that we use that maintain product purity, have a decent flow rate, and high reliability for maintenance can compress to, in the early days, 200 bar, but now we're seeing many applications for 350 bar trailers, 500 bar, even 1,000 bar. And that's clearly served by our PDC equipment. So this is supposed to represent, if we had one PDC-3, how many trailers could it fill a day? About 1. If we had a PDC-13, how many trailers could it fill a day? For a 200 bar trailer system. So what we're trying to demonstrate is we have a range of products to support whatever our customers need in this market. How this is translated today is that instead of having a liquid tank as the primary source, we oftentimes, many times, see electrolysis as the hydrogen source for our products. Now, a diaphragm compressor being a positive displacement machine, the higher pressure we provide to it on the inlet, we're going to get a greater flow rate on the outlet. It also helps with the temperature balance of the system. It's a more efficient compression. So we definitely like the application of mating electrolyzers with our equipment. The equipment that we have right now, in the early days, we saw a lot of 75 kilogram a day or less applications. Those are mainly used in the power industry for generator cooling. Many electrolyzers throughout the world doing that right now. Then we started getting into more the 200 a day systems that suited the PDC-4. Now we're getting into 1 megawatt, 420 kilograms a day, 5 megawatts, 2,100 kilograms a day. That's all suited for the PDC-13 machine. So what we often do with customers is they come to us with a request with a flow rate from a compressor, a flow rate from an electrolyzer, excuse me. We match up a compressor for them. But in this process, we often help the customer size the system, make sure everything functions symbiotically, because a compressor can not just be dropped into any system and work well. So this is a typical system that we'd provide. In this application, though, when the electrolyzer is not filling vehicles, many times we fill gaseous hydrogen trailers, and those trailers can be usually taken to a remote location, fed back into a compressor, and used for dispensing again. We see this application all the time. This would reduce the compressor, as we can see here, this would be a 3-stage unit, initial stage, and then second and third stage. But when we have higher pressure to it, it reduces it to 1 stage. So it requires less power, again, more efficient. Compressors are also used extensively in liquid pumping applications. Oftentimes, these are very high capacity liquid pumps that may do 200 or 300 kilograms an hour or more. However, they do generate hydrogen because hydrogen does not like to stay as a liquid. It wants to be gas. In these applications, we oftentimes put in PDC compressors to save the gas that's sent back to the hydrogen tank, and instead of lifting the relief valve in the tank, we draw it into our compressors and return to the storage tubes at whatever pressure that's required, 450, even 900 bar, it doesn't really matter to us. That's a very low pressure application. Going from a low pressure to a high pressure usually requires 3 stages. Another application that we work on, we can't list them all, but we have biogas applications. Biogas is basically SMR technology, almost. We see these applications with diaphragm compression systems very well. And this also works as long as we have pure hydrogen coming into a diaphragm compressor. We got to remember, good purity in always equals good purity out. Contaminated hydrogen in is going to foul the machine and cause decreased service life. But compressors can also be used if we want to avoid the boil-off issue directly. And in this instance, we would use 2 compressors for redundancy to achieve the same effect as a single liquid pump. But in this case, with gaseous compression and cryogenic hydrogen storage, we don't have the boil-off issue because gaseous compressors take the gas off the headspace of the cryogenic tank, and there's no waste. So you can see there's many applications here. One application I haven't hit on is the manufacture of green ammonia we're involved with. The other one is electric from nuclear power, how that's integrated into the electrical supply chain. We have a lot of experience in many different applications with these compressors. But what I often get questions from customers is they come up and say, how much is a compressor for a 700 bar station? They say, how much does a hydrogen fueling station cost? This is not a, there's not a number for a question like that. What's needed is a long discussion to go over their requirements. It's easy to say, oh, I have 30 bar coming from electrolyzer at 30 degrees Celsius, and I need 500 bar in my storage. But we often don't get that. So PDC's probably greatest asset is our desire and our ability to partner with our customers, talk with them extensively, help them source out their equipment. So naturally, the questions have to revolve around what types of vehicles are you using? Light duty, medium duty, or heavy duty? That's directly related to what's the tank size of the vehicle? How many tanks do we fill back to back? What's the pressure of each vehicle? We know we're going through this crazy situation where we're working with Class 8 heavy-duty trucks at 700 bar. We have buses at 350 bar. We have light duty at it could be all over the map. Do you want multiple vehicles to fill at your same dispenser? Are you going to add vehicles in the future? How's the capacity going to scale up with your increased vehicle demands? What's the fueling profile? We know that buses normally fill when they come back from their routes between 6 p.m. and 2 a.m. What's the fueling profile of all your vehicles? This was really how we know to work with our customers, ask the right questions, help them scope it out, work with their EPC, and eventually, hopefully, sell a compressor to them. So we have a lot of experience in this area. Because we've had so much inquiries about hydrogen systems, we started getting into looking at small stations. So one product that we offer with our partner Ivis is a 20 kilogram a day electrolyzer, compressor, storage in a box, and a dispenser. So this unit's configured to either run at 350 bar for material handling or 700 bar for vehicles. What we have here is a 20 kilogram a day PEM electrolyzer. So over the course of 24 hours, it will make 24 kilograms. There's onboard storage at the top, a minimal amount, 5 kilograms to meet the codes and standards. Then we have a PDC compressor on the bottom, the smallest one we discussed previously, the PDC-3. And then fueling either, as I mentioned, for 700 bar or 350 bar. So packaging this into one unit, it can be done in a slow fill or a J2601 3 to 5 minute fill for 700 bar. You know, it's quite an accomplishment and helps people get over that hump of initially putting in a complex station. Because we all know if we're putting in a transit station, we're going to need big equipment, big plots of land, a lot of excavation, concrete work. It makes it very simple. The codes and standards around this box are very favorable to being installed anywhere, and the power required is usually the power that's already available without going to your electrical utility and getting a new transformer put on the pole. It's an example of it. But as I wanted to say too, PDC does sell compressors. It's our main part of our business. We don't want to forget the aftermarket, because without support of our equipment over the long term, we wouldn't have the repeat customers that we've enjoyed for the last 45 years. So new to PDC this year is that we've worked with Industriality to create mypdcmachines.com. So every new machine that goes out will have an asset tag on it. The asset tag takes you directly to My PDC Machines website, where we have a digital twin of your asset. So this calls up all the drawings associated with it, maintenance manuals, has videos on how to perform the maintenance. And when you scroll through the machine and take off layers, you physically see which parts are incorporated in the machine. Click on them. It's linked to a spare part that you can order yourself off the website. So let's not forget support. Myself and the rest of our PDC team will be glad to meet you. We have people from all over the company, myself in the product department, R&D engineers to talk about technical sides of the product. We have Bree McQuillan here to discuss any aftermarket questions you'd have, especially about My PDC Machines, and Osama Al-Qasim, who's our Director of Government Affairs. But thank you for attending the presentation today. I appreciate it.